Alrighty, so if we're finding the relative extrema and classifying them, I need to find the first derivative, find the critical points, find the second derivative, plug in the critical points, and then it tells me if it's a max or a min. So let's see how well you guys did. I'm hoping you at least remembered how we find the derivative. But hang on, my thing is not writing everywhere. So I need to change this. There we go. Okay, so I'm hoping you at least found the first derivative, yeah?
Yes.
Excellent. Matthias, what's the first derivative?
3x to the power of 2 plus 4x plus 1.
Good. So then you needed to make that thing equal to 0, which meant that then you needed to factor it. Guys, who's got music playing? Okay. So it's going to be multiplying to 3, adding to 4. What two numbers? 3 and 1. So it's going to be x plus 1, 3x, sorry, plus. Oh my gosh, my brain's not working. Yes, 3x plus 1. No, is that right?
No. Yes.
3x squared, 3x, x. Yes, okay, good. Wow, that was a pain. Yeah, go. All right, so that means that my solutions are going to be when x is -1 or -1/3. Excellent. Okay. Then I need to find the second derivative. Man, my brain just stopped working there. That was weird. Second derivative, I'm just going to take this one and do it again. So
6x plus 4.
excellent. Then do I need to make it equal to 0? No, not this time. What I need to do is plug in these two things. So I'm going to find f double prime of -1. And all I care about is the sign. I don't actually need the answer, so I know that this is negative. Or if you prefer, I could write it like this. And then I'm going to find the second derivative at, sorry, not at x, but at -1/3. And if I do that, I'm going to get that it is positive. So if it's positive, it's concave up. If it's negative, it's concave down. Therefore, I can classify these. So if -1 is concave down, what is that?
Max.
This is a relative max. And this one here is a relative min. Okay? And if you want to, you can say that it's because of these things, right? It's because f double prime of -1 is negative. So you can say because f double prime of -1 is negative. And over here, it's because f double prime of -1/3 is positive. Amazing. Today after school, Tuesday after school, Friday after school, Wednesday after school. I don't. Wednesday during X block. I don't like after school. It's just that I'm here, so if you want to do it, you can. X block is the official answer.
You don't like lunch?
It's too short. It's not long enough for this test. This test is too long. Alrighty, so since the second derivative is the first derivative, hey guys, listen to this. You got to remember this. Matthias, stop laughing. Pay attention. Emilio. The second derivative is the first derivative of the first derivative.
What?
You heard me. Then the same relationships exist between f and f prime as between f prime and f double prime. So therefore, if the second derivative is 0 or undefined, then the original has a potential what?
POI.
Exactly. Point of inflection at poi. And if the original function has a point of inflection, that would mean that f prime has a potential max or min, because the second derivative is the first derivative of the first derivative. So if it's 0, then that would mean that the first derivative has a max or min, potentially. All right. If the second derivative is positive, then the original function is concave up. And the first derivative is increasing. If the second derivative is negative, the first function, or the original, is concave down, and the first derivative is decreasing. Right? Because if you think of this as being the first derivative of this first derivative, if it's negative, that would mean it's decreasing, right? Same relationship exists. If it changes from positive to negative, these two here are the same, and they're just that there is a point of inflection, right? Doesn't matter which way it changes. But it does matter which way it changes for the relative max or mins. So if it goes positive to negative, the first derivative has what? Relative max, right? Positive to negative, it's going increasing and then decreasing. All right, and then negative to positive, it's decreasing and then increasing, so relative min. Amazing. How do we all feel about that? Why bad? Okay, well, she said normal, so we're going to go with her answer then. Amelia's answer is the one we're going to take. All right. So we're going to consider the function h prime of x equals 2x minus x sine 2x on the open interval from -5 to 5 to answer the following questions. Based on the graph of h prime of x, how many relative extrema does the graph h of x have? Give a reason for your answer. So, yep, we can pull out your calculators. So 2x all right, and we're only supposed to be looking at this thing from -5 to 5. So if I look at it from -5 to 5, how many times does it cross the x-axis? Once. Therefore, how many relative extrema are there? One. Because h prime of x crosses, no, let's say changes sign. That's a better way to say it. Changes sign exactly once. That makes sense to everybody? Pertus? You good? All right. Based on the graph of h prime, how many points of inflection does the graph of h of x have? So remember, it's going to have a point of inflection, right, if the derivative has a max or a min. So if we go look at it, how many max or mins does it have? Well, it's got 1, 2, 3, and we're kind of missing it here. Looks like 4. So here, let me change that so that this is a little bigger. Let's go -10 to 10 to make sure we've got them all here. Looks like we got 1, 2. Oh, we need to go a little smaller even.
Mr. But super quickly, IVT is continuity, right? IVT.
Yeah. So look, I got 1, 2, 3, 4. Oh, 5. Takes you a little bit longer, but you can just see them. So this means that there's going to be 5 of them, right? So 5 because h prime of x has 5 relative extrema. Does that make sense to everybody? Maybe? No? You're unsure? Are you smiling because you agree, or? Excellent. All right. What about the next one? Find the equation of h double prime of x, and then graph it on our calculator, and explain why the graph of h double prime of x confirms our responses from question 2. All right, well, they gave h prime, so let's start with that. So h prime of x was 2x minus x, right? Minus x sine of 2x. Yeah, that's it? All right, perfect. So then h double prime is going to be 2. This here is going to be a product rule, right? Because it's x times sine, and it's also a chain rule. So it's going to be the derivative of the first times the second plus the first times the derivative of the second, which is 2 cosine. It is. That's why I wrote cosine. Remember, I got to do the derivative one at a time. I don't take the derivative of them both for product rule. And then I said to graph it and confirm our answer. So let's graph it. We can even do it the fancy way. We can call this like f of x, and then we can say d dx of f of x. Now, just to prove to you that that is actually what we needed, this was 2 minus sine 2x minus 2x cos 2x. There, see? So you can take the shortcut or not, doesn't matter to me. All right, and what we're looking at here is we wanted to confirm the first one. So that would mean that if it had, what was it, points of inflection, that would be when the second derivative has zeros. 1, 2, 3, 4, 5. Exactly what we guessed, right? So it confirms it for us because h double prime of x, let's say changes sign exactly 5 times. Does that make sense? So this confirms this, right? It confirms it. Because we said, oh, if it's got 5 max or mins, 5 relative extrema, then it should have, the second derivative should have 5 zeros, and it did. And that means the original has 5 points of inflection. I did. Derivative of 2x is 2. This 2x? I did, it's 2. I just put it in the front. Yeah. The limit of the derivatives are equal.
So I find the derivative of these and then I find the limits.
Exactly. All right, let's see if we can figure these things out then. Ready? We're just going to fill out a bunch of reasoning for us. So, based on the relationships between a function, its first and second derivative, complete the following statements. F of x is increasing, then the derivative is doing what, Emilio? Out of time, he gets a 0. Miguel?
Are you asking? But you said Miguel.
No, I said you. All right, if f of x is decreasing, Emilio, what is f prime doing? No, it's less than 0. Okay. If f of x has a relative max or min, then f prime is doing what, Pedro Yacaman? Yacaman, you have such a pretty voice. Changing signs, yes. If f of x has a point of inflection, then the first derivative has what, Matthias? Relative max or min. No, it has to have it. Has to have it. And that would mean that f double prime changes signs. Okay? All right. If f of x is concave up, then the second derivative is?
So when f double prime of
Zero
less
or
than
Huh? If it's concave up.
We don't.
Greater than 0. And you guys, the first derivative is increasing. Okay? You got to think about which one we're talking about. The first derivative is increasing. The second derivative, therefore, is positive. Okay?
If double prime is 0 or
Then it's a potential point of inflection.
so when it changes sign, it is a positive.
It is, exactly. All right, if the original is concave down, Jack, what is the second derivative doing?
Decreasing.
No. Less than 0. And Jack, the first derivative is decreasing. Okay? You got to really think about which one we're asking about here, guys. Because both of these things are true. All right, if it has a point, if the original has a point of inflection, then the second derivative, no, changes sign. Changes sign guarantees it is equal to 0 or undefined, says there's a potential one. So if we want to guarantee it, it has to change sign. And we could say that f prime of x has what? It has a relative max or min. All right, now let's switch up from f to f prime. So if f prime is increasing, then f double prime is,
Greater than 0.
yeah, it is. And the original,
Concave up.
I love it. Exactly, concave up. Okay, if f prime of x is decreasing, this one is less than 0, and the original is concave down. Okay? F prime of x has relative max or min, then f double prime of x changes sign, because we know for sure that it has that point of inflection. So it has to change sign. Good. If the first derivative has a point of inflection, then the second derivative, which would mean what?
Okay. I don't know.
No. 0 means that there's a potential one. How do we know for sure? Relative extrema, guys. Right? Remember, the equals 0 just means potential. So if we want to say, hey, for sure it has one, which it will with this point of inflection, we should say it's relative extrema. It's got like a max or a min. All right, if the first derivative changes from negative to positive. What, sorry? Concave up. Oh yeah, because we're talking about the original. No. Guys, this here is the derivative. So if it goes from negative to positive, the original, there we go, relative minimum. And if the derivative goes from positive to negative, the original, relative max, but yes, or local if you prefer. If the first derivative has a relative max or min, then the original function, yes, point of inflection, right? Because that would mean the second derivative changes sign, which means that the original is a point of inflection. And if the second derivative goes from positive to negative, in other words, it's showing the original function as a point of inflection, then the first derivative has relative max. And if the second derivative goes from negative to positive, relative min. So you guys, you have to just really think about it and remember that the second derivative is the first derivative of the first derivative. So all the same rules apply. Okay? And now we're done. And I've got an activity for you guys that you're going to fill out here. So I'm going to I'll pass it out to you, okay?